Consider an example of modeling a blending operation. Our problem definition is to predict how the temperature of stream 3, the blending operation effluent, varies in responses to changes in TH, the temperature of the steam supplied to the heating coil. Step 1A, our problem definition, is done for us. Here, we'll select the unit operation scale since we are dealing with the flows of energy and material into and out of an operation. And we'll want our model to be a dynamic model since we want to know how the temperatures vary with time. The next step is to draw a conceptual picture. The picture is also already provided for us. Notice in this picture we included important streams and quantities or process variables that might appear in our model have been labeled and assigned symbols. Furthermore, our conceptual picture implies several assumptions about the model. That's step 1D. Here we'll assume that the tank is constant volume and that it's perfectly mixed. That is, we don't have to describe temperature or composition gradients within the tank. We'll also assume that the mass flow rates m.1 and m.2 and the temperatures of the streams entering are constant. We'll also assume constant fluid properties such as density and heat capacity. We'll assume that the tank is adiabatic, and we'll assume that there are no chemical reactions. Finally, we'll assume that there is no conversion of shaft work to thermal energy. You can already begin to see how some of these assumptions will simplify our model equations. Many of these assumptions, such as the assumptions of constant fluid properties, insulation of the tank, chemical transformations, and conversion of shaft work to thermal energy, are made simply because we have no information to the contrary. If we were to assume that there were chemical reactions, we would then have to build additional assumptions about what those chemical reactions are, their rates, heats of reaction, etc., which we have no information about. Next, that completes the 4 steps in the problem definition. Next, we'll talk about how to formulate mathematical models, and we'll continue with this example.